Welcome to episode 16 of the Head in the Clouds video series. I am Ken Hartman, a SANS certified instructor and content creator for the SANS Cloud Security curriculum. Today's episode is titled Introducing GitHub Codespaces, Dev Environments as Code. In prior episodes of Head in the Clouds, we talked about the benefits of infrastructure as code and how we can easily provision cloud resources with a script. However, to deploy the infrastructure as code, one must have the necessary dependencies in place, such as the credentials and the infrastructure as code tools, such as, say, Terraform. Different development projects require different dependencies. So wouldn't it be awesome if we could quickly and easily provision a development environment for each moments before we needed it and tear it down when we are done working for the day? That is the idea behind development environments as code. Dev environments as code can be thought of as a special type of infrastructure as code. GitHub Codespaces is one of many service providers that offer dev environments as code, and this particular service is the topic of today's episode. Before we jump into the particulars of GitHub Codespaces, let's answer the question that you may be asking yourself. Well, I'm a security person, not a developer. Why do I care about this? Well, expand the idea of dev environments as code to security testing environments as code, or learning environments as code, or perhaps it makes more sense just to think in terms of environments as code. Regardless of your role, I think that the idea of being able to jump right into work is much more appealing than having to invest a lot of setup time before getting into the important work. To use GitHub Codespaces, you have to have your GitHub account associated with a team plan or enterprise plan that has authorized your GitHub account to use the Codespaces functionality. The easiest way to do this, if you do not currently have access to Codespaces yet, is to subscribe to the team plan for $4 per user per month, even if it is just for the single month. And yes, you can have a team consisting of just a single user. That's what I did, except for I chose the annual billing plan to simplify my bookkeeping. Go ahead and set up the organization that you plan to associate with your new team account. For example, I called my new organization Rampant Lab. Okay, now that you are subscribed and set up your team account and organization, you need to grant your account the permission to use Codespaces. At the organization level, click on Setting and then select Codespaces in the left-hand menu. Set the user permissions to allow at least your GitHub user account to access Codespaces. Also set the Access and Security radio button to all repositories for now. Great. Now we can create a new repository that is owned by our new organization. Call the new repo Space1 or something like that. If you want, provide an optional description and leave the repository private. Add a README and a license file like Apache 2.0 while you're at it. Then click the Create Repository button. Now click the Add File button and select Create New File. Call the new file hello.py and add the following line of code. And then click the Commit New File button. Don't worry if you don't have Python installed. The default Codespace does. Let's check it out. Click the green Code button and then select the Codespaces tab. Note, if you do not see the Local and Codespaces tab, you're either not in your organization or you did not grant your account access to Codespaces as described in the Setup step. Next, click the New Codespace button, choose the To Core option, and click the Create Codespace button. Within 2 or 3 minutes, the Codespaces service will spin up a container to serve as your environment, and the web browser will load the Microsoft Visual Studio web-based integrated development environment with our repository set as the working directory. The container that gets spun up is on a dedicated Linux virtual machine so that you can have full access to all of the resources of the virtual machine, including full root access to your container. At the prompt, type ls and notice the 3 files from the repository are shown. We can even run the Python program by typing python hello.py. Click on the hello.py file in the Explorer pane and then edit hello.py by replacing hello world with head in the clouds. Rerun it to observe the change. Since our change works, let's commit the change. Run the following commands in the terminal pane. We have just pushed the change from our local development environment, which is running in a cloud container, up to our repository in GitHub. We can look at it in the repository by clicking the blue Codespace button in the bottom left-hand corner and selecting the Go to Repository option. Notice that the commit comments that read revised hello.py show our last commit was indeed pushed. To get back to our Codespace, click the green Code button again and then select the running Codespace. To prove that we have root access, type sudo su. Very cool. Type exit to lower our privilege level back down. The default Codespaces container supports many different languages, not only Python, but Java, Go, C++, and a few others. You may have noticed that it does not support all of our cloud command line interfaces. To prove it, run the following command. Which AWS AZ gcloud? Interesting. The only one that the default image supports is the Azure CLI. I wonder who owns GitHub these days. Is Terraform installed? Looks like it isn't installed either. The default image is maintained at the following Microsoft GitHub repo. So consult this repo to learn more about it. There are many more standard definitions to choose from as well, and these can be found in this same repo. If we wanted to install the AWS and gcloud command line interfaces on our Codespace environment that we just launched, we could, since we have full control. But then we would have to run through the manual install process each time we spun up a Codespace. That would be rather inefficient. Besides, we want to be able to hit the ground running without any additional setup. One option to customize our Codespace environment is to use dotfiles. Dotfiles take their name from the fact that many of the files used to configure a Linux or Mac are hidden by virtue of the fact that the first character in their name is a period. There are a couple of steps to setting up Codespaces to work with dotfiles. First, we need to create a public repository named dotfiles in our personal GitHub account. And then, second, we need to enable Codespaces to use our dotfiles to configure Codespaces for us. In your personal GitHub account, create a new public repository named dotfiles, then create a file named setup.sh in the new repository that contains the following lines as shown on screen. The next step is to enable Codespaces to use our dotfiles. Click on the profile photo in the upper right-hand corner of the GitHub webpage and select Settings. In the new page that loads, select Codespaces in the right-hand menu. Now click the Automatically Install dotfiles checkbox. To test that the dotfile script will execute, let's create a new Codespace for our Space1 repository. Navigate back to your organization and select the Space1 repository. This time, instead of selecting the running Codespace, click the Manage All link. Click the ellipsis, the 3 dots, on the row that lists the running Codespace, and then click Delete. Now click the New Codespace button, and then click Create Codespace. Once the prompt appears, run the following command to confirm that Terraform is installed. which Terraform. And bad news, Terraform is not installed. GitHub has a good troubleshooting document, so let's consult it. Okay, well, to see if our .files were cloned, we can run this command. Looks like it was cloned. Next, let's check the creation log. Well, it looks like the issue is that our startup.sh script is not executable. Unfortunately, this script cannot be made executable via the GitHub web UI, so I will clone it down to my local system, use chmod to make the file executable, and push it back to the repo. For this episode, I will not be demonstrating how to do that since this episode is not on GitHub Basics. We do, however, want to test it now that we've made this fix. Click the blue Codespaces button in the lower left corner and click My Codespaces. Delete the active Codespace and create a new one. Now, when we run which Terraform, we see that it is indeed installed. The installation of Terraform after the container spins up using the .files technique is not terribly slow, but if we were to install the CLIs for the other clouds, it would add a considerable amount of time. And that is exactly what we're trying to avoid. So that brings us to the other option, using a custom image. The benefit of using a custom image is that we can install all the software that we need for our development environment and leave anything that we do not need out of it. Fortunately, we already have a container image that has the command line tools for all three cloud service providers, as that was the subject of episode 15. To experience this, create a new repository named Space2 that is owned by the organization that granted you Codespace access. Leaving it as a private repo is fine, and add a README file. Click Create Repository. Create a file called .devcontainer.json and add in the following content. Then commit the change. Note, even if you followed along with episode 15 and made a public image in Docker Hub, you may still want to use my image, as I have made some changes to the image since publishing that episode. After completing the lesson in this episode, you can fork my hitc-tools repo and build your own custom images derived on that. To test if Codespaces will use the specified container, spin up a Codespace in this repository after deleting any unneeded running Codespaces. Once the prompt appears and the .file configuration completes, run the following command, which AWS, AZ, gcloud, Terraform. And we should see the following output showing that all of them are installed. Great, this worked, but it'd be even more efficient if we installed Terraform in the container image and turned off the .files. Generally, it makes sense to build a container that has everything that the entire team needs and to allow each user to make minor customizations via .files in their personal repo. The GitHub hitc-tools repo was updated with the following commit so that the resistor hitc tools episode 16 container image would have Terraform installed. So let's switch to that image in our devcontainer.json configuration for our Space2 repository. The contents of the devcontainer.json file should now read as shown on the screen. Turn off the automatically installed .files setting in our personal settings, and then launch Codespaces again. Notice that the prompt appears in short order, and there's not the additional delay of the .files process needing to install Terraform. We can confirm that all 4 of our CLI tools have been installed, including Terraform, using which. Now that we have a basic Codespace configuration, there's still some additional configuration that we will need to do. First, run the following AWS command, AWS STS get caller identity. Notice we get the following unable to locate credentials error. Of course, we have to configure our credentials. And while we could do that via the AWS configure command in the terminal, well, then we would have to do it every time we needed to spin up a new Codespace for this repository. Fortunately, the solution to this is to use Codespace Secrets. Codespaces has a facility to store the secrets that each user needs to work with external services from their Codespaces. The secrets are stored by the Codespaces service in an encrypted format and are only exposed to the Codespaces that you designate by setting the secret as an environment variable as the container is launched. The AWS command line interface documentation specifies various environment variables that can be used to set configurations needed by the CLI. The 3 that we are most interested in are AWS Access Key ID, AWS Secret Access Key, and AWS Default Region. The first 2 are sensitive, so we will set them as secrets, and the third one is not sensitive, so we will set it via the devcontainer.json file. Navigate to your personal GitHub settings by clicking on your avatar in the upper right corner and selecting Settings. Then select Codespaces in the right-hand menu. The Codespaces Secret section is right below the dotfiles setting that we were interacting with earlier. Click the New Secret button. Type the name of the secret exactly how you want it to appear as an environment variable. Next, provide the value of the secret and select the repositories that will need the secret. Note that you can always update the secret value later, but you cannot get it to display when you click the Update button. You can also add or remove the repositories that the secret is available to at any time. You should create a new identity that is dedicated to Codespaces and generate a new AWS Access Key and secret. The reason that I recommend a dedicated key is that by using dedicated keys for different purposes, it's actually easier to detect and isolate a key compromise. For the AWS region, we will add a line to the devcontainer.json file. So update that file so that it looks like the following when you are done. With that done, let's spin up a new Codespace for our Space2 repository, and let's test it. Rerun the AWS STS get caller identity once the prompt appears. We should get a result that looks like what is shown. Awesome. Now we're going to run env pipe grep AWS. And you should see something like this, the environment variables. Don't worry, by the time you see this video, these secrets will have all been rotated. For Azure, we need to generate a service principal. The easiest way to do this is to log into your Azure portal and use the Cloud Shell and run adsp create for RBAC. And you will get output that looks kind of like what's displayed on screen. Note that by default, the command that we ran in the Cloud Shell created a service principal with the contributor role for the whole subscription. Is it over-permissioned? Well, yes, most likely. And that all depends on what permissions the repositories that we create will actually need to do. Most importantly, be sure that you protect these credentials. Next, while referring to the output from your Cloud Shell, set the following 3 Codespaces secrets as was done for AWS. Since we want to be able to run Azure CLI commands as soon as the container boots up, we need to add a configuration to the devcontainer.json file that logs us into Azure but uses the secrets that were set as environment variables. So here is the command to do that. So we would need to make the devcontainer.json file read as follows by adding in the line with the post start command. Great. Let's test the latest incarnation. Delete any previous code spaces and spin up a new one for the space2 repository. To test it, run the following command once the prompt appears: az account show. And the returned results should look like: in GCP, create a brand new service account called Codespaces and grant it the editor role. Yes, this is a very powerful account, but we want it to be able to do everything but grant IAM access. Next, create a new JSON formatted key. The key will download. I've covered how to do this in previous Head in the Clouds episodes, so we're just going to assume that the key is already downloaded. Now we need to base64 encode the service account key. Assuming that the only JSON file in your downloads directory is the key, we can use the following command to convert it. Open up the keybase64.txt file and create a Codebases secret. Name the secret GCP_key and paste the entire contents of the file as the value. Create another secret called GCP service account and paste in the name of the service account. The name should be in the format of codespaces at yourprojectid.im.gserviceaccount.com. Make sure that the repositories selected for both are set to space2. Similar to the trick that we did with Azure, we're going to run a command post-launch to log our codespace into GCP. The command we will use is, so that will make the new devcontainer.json file look like the following. Note that the remote env name value pair in the JSON also adds a new environment variable, the GCP project ID. Be sure to set this as appropriate for your GCP project. Time to test our handiwork. Delete any previous code spaces and spin up a new one for the space2 repository. Run the following command once the prompt appears. Looks good. And while we're at it, let's confirm that the AWS and Azure authentication still works as expected. Awesome. Everything works as expected. Well, there you go. We've covered a popular trend in cloud-based development called development environments as code. And we looked at GitHub's implementation. We looked at the default container and showed how a GitHub user can use dotfiles to customize it for their unique preferences. After that, we used a .devcontainer.json file to customize the development environment for the specific needs of our repository. In this case, our goal was to have a dev environment that allows us to run CLI commands or Terraform scripts against all three of the top cloud service providers. To do that, we had to leverage Codespaces Secrets to avoid having authentication credentials in our configurations. If you have thoughts or comments on today's episode, feel free to chime in on the comments for this YouTube video. If you appreciate this video and want to see more like it, well, be sure to give it a thumbs up. Stay tuned for another installment of Head in the Clouds, as announcements of new episodes are made on the SANS Cloud Security Twitter feed. Meanwhile, be sure to check out the other great videos on the SANS Cloud Security YouTube channel. Take care.